Get ready for a cosmic disaster on a scale never seen before. Betelgeuse, a massive red supergiant star, is sending terrifying signals across space that have caused alarm among scientists and astronomers alike. This star, one of the most well-known objects in the night sky, is behaving in ways that suggest something profound is happening deep within its core. Using advanced technology such as the James Webb Space Telescope, astronomers have uncovered evidence that points to a possible catastrophic event that could unfold soon. Renowned physicist Brian Cox has even issued a serious warning about the potential dangers we may face. The central question that everyone keeps asking is, are we on the verge of witnessing a supernova explosion so large that it will forever alter the night sky? Such an event would be monumental, marking a cosmic catastrophe never before observed by humanity. In the vastness of the universe, stars are constantly born, live out their lives and die in astonishingly dramatic ways. Yet, one star in particular has recently captured the attention of both astronomers and the general public. That star is Betelgeuse, a red supergiant with a history as mysterious as its recent behavior. Betelgeuse is not just any star. It is a red supergiant star that dominates the cosmic constellation of Orion. This star is massive, incredibly old, and has been observed for centuries due to its distinctive reddish color and fluctuating brightness. For generations, people have been fascinated by this celestial giant, but recent developments have intensified that interest. Betelgeuse is a star of significant scientific importance because it represents a stage in a star's life cycle that is not only rare but also immensely powerful. As astronomers study this colossal star, they have started to detect signs that it may be approaching a critical moment in its life. We are, in fact, on the verge of witnessing a major event in its history. The nature of these changes remains uncertain, but they may signal the start of a cosmic spectacle of unimaginable scale. The behavior of Betelgeuse is raising questions about whether we are about to see one of the most incredible phenomena in the universe, a supernova explosion. Betelgeuse is truly a stellar giant. To give some perspective on its size, it is about 900 times larger than our Sun, which is already enormous by human standards. This size is almost beyond human comprehension. Imagine if Betelgeuse were to replace our Sun in the solar system. Its surface would extend far beyond the orbit of Mars, enveloping Mercury, Venus, Earth, and Mars. Its sheer size is one of the most impressive aspects of this star, and it gives us a glimpse into just how extraordinary the universe can be. However, Betelgeuse's size also provides a clue about where it stands in its life cycle. It is a red supergiant, meaning that it is nearing the end of its life. This phase comes after a star has converted most of the hydrogen in its core into helium, causing the star to expand and cool. Betelgeuse, believed to be between 8 and 8.5 million years old, has undergone dramatic changes over millions of years, transforming into the red giant that we see today. The star is now in its final stages as a red supergiant, a phase characterized by immense instability as it prepares for the possibility of a supernova. Stars like Betelgeuse experience significant changes during their lives due to the constant pressure from nuclear fusion in their cores and the force of gravity pushing inward. What makes Betelgeuse so unique at this stage is its distinct reddish hue, which is a clear sign of the star's temperature and its current state in the life cycle. The reddish color of Betelgeuse is not just for show, it reveals a lot about the physical state of the star. Betelgeuse's red hue is due to the fact that its surface is significantly cooler than that of stars like our Sun. For example, the Sun's surface has a temperature of approximately 5,500 Kelvin, whereas Betelgeuse's surface is much cooler at around 3,500 Kelvin. This lower temperature causes Betelgeuse to emit light at a wavelength that makes it appear red to the human eye. But the color is more than just an aesthetic feature. It is an indication of the processes occurring within the star. The star is undergoing dramatic internal changes as the last remnants of nuclear fusion begin to wind down, altering the physical state of its massive gaseous layers. Over the course of history, the color of Betelgeuse has changed, showing us that stars evolve in real time, even if we don't always notice it. For instance, during the Roman and Chinese eras, Betelgeuse was described as being yellow, which was approximately 2,000 years ago. By the 9th century, Arab astronomers were among the first to note that Betelgeuse had turned red. This shift in color over time provides insight into the complex life cycle of stars and how they change as they approach the end of their existence. In addition to its changing color, Betelgeuse is also known for its variable brightness, which has captivated both scientists and skywatchers for centuries. Betelgeuse is classified as a variable star, meaning that its brightness changes over time in regular cycles. This variation is part of what makes the star so fascinating. Over the course of hundreds of years, astronomers have observed that Betelgeuse goes through a bright cycle that lasts about 400 days, along with a longer cycle that spans 5 years. These fluctuations in brightness were first documented as early as 1836 by the astronomer Sir John Herschel, and it's possible that Aboriginal stories about this star predate even that. However, what really sets Betelgeuse apart from other stars is how unpredictable its brightness can sometimes be. While many variable stars follow consistent patterns, Betelgeuse has been known to deviate from these regular cycles, suggesting that there may be other, less understood processes at work within its massive structure. This irregularity adds to the mystery of Betelgeuse, making it a subject of continued fascination for both scientists and amateur stargazers alike. In recent years, Betelgeuse has once again captured the world's attention with a phenomenon known as the Great Dimming. In late 2019, astronomers and skywatchers around the globe noticed something unusual. Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the constellation Orion, began to dim in an unprecedented way. The star's brightness started to fade at a rate of 0.01 magnitude per day, which was far faster than expected. By February 2020, Betelgeuse had reached its faintest level in recorded history. This was particularly strange because Betelgeuse is usually bright enough to be seen with the naked eye, even in areas with significant light pollution. But during this period, the star became noticeably dimmer, and even casual observers could tell that something had changed. However, there is a challenge when it comes to observing Betelgeuse. The star is located about 654 light-years away from Earth. This means that when we look at Betelgeuse, we are actually seeing it as it was 654 years ago, due to the time it takes for its light to reach us. This time lag complicates efforts to study rapid changes in the star's behavior in real time. The Great Dimming event was a stark reminder of how difficult it is to observe the night sky in real time and how little we truly understand about the universe. The event also highlighted the challenges that come with studying distant celestial objects like Betelgeuse, where time and distance create significant obstacles. Despite these challenges, astronomers have been working tirelessly to understand what caused Betelgeuse to dim so dramatically. Andrea Dupree, the deputy director of the Harvard-Smithsonian Center for Astrophysics, led a team of researchers in a 3-year study to track changes in Betelgeuse's outer atmosphere using the Hubble Space Telescope. They were able to observe the star in unprecedented detail, particularly in ultraviolet light. These observations revealed new insights into how variable stars like Betelgeuse function. Variable stars, as their name suggests, expand and contract regularly, which leads to changes in their brightness. In the case of Betelgeuse, the researchers observed that material from the star's surface was moving into its atmosphere at incredibly high speeds, up to 200,000 miles per hour. This material eventually traveled millions of miles away from the star and contributed to the formation of a dust cloud that made Betelgeuse appear less bright for several months. The mass ejection from Betelgeuse was particularly significant because it occurred at a much faster rate than scientists had expected. Dupree and her team estimated that twice as much material from Betelgeuse's southern hemisphere had been ejected during this event. This mass loss was so dramatic that it raised questions about whether Betelgeuse was preparing for a supernova explosion. Supernovas are among the most powerful events in the universe, occurring when a star reaches the end of its life and explodes in a blaze of energy. Given how large the mass release was and how faint Betelgeuse became, astronomers began to wonder whether this event might be a precursor to such an explosion. At a distance of 654 light-years from Earth, Betelgeuse is relatively close in astronomical terms, and a supernova from this star would be visible from Earth. It would offer humanity a rare opportunity to witness a supernova up close, a sight that has not been seen in our galaxy for hundreds of years. However, the question remains, is this a sign that a supernova is about to happen, or is it simply a one-time event in the long and complicated life of Betelgeuse? Several theories have been proposed to explain this rapid change, and astronomers continue to study the star in hopes of uncovering more answers. Let me know what you think in the comments box. If you liked the video, be sure to like and subscribe and also turn on notifications.